So the final column that we'll talk about is an affinity column chromatography. And for this, we typically use some special feature about the protein, perhaps even its function, in order to help separate the protein. So for example, you can have proteins that bind the sugar maltose or bind the complex carbohydrate called chitin. And if you functionalize the resin with either chitin or maltose, then proteins that whose function are to either bind maltose or chitin will specifically bind to the beads. And most proteins within the cell that you have your lysate from aren't going to bind to these molecules, but the protein that you're really interested in will. And that way you can wash out the rest of the proteins, and then what you leave behind is simply the protein bound, and then the protein bound to the column, and then you elute that in some way to let your protein release from the beads and then out of the column. So another method is called immobilized metal, and so for this the beads are functionalized with carboxylate groups that bind nickel or cobalt. And then proteins can be bound with what's called a which is called a his tag, which is just a chain of 6 histidines in a row. And these bind really tightly to the cobalt or the nickel in the column. And in this way, this is usually done by some sort of genetic engineering. And in this way, since you have to add this tag to the protein, only the protein that you're really interested in purifying binds to this metal column. Everything else washes through, and then you can elute the protein off with a molecule called imidazole, which will outcompete the histidines for binding to the metal, and then that will release your protein.